Good morning, everyone. This is Miss Morello here with a short little introduction to what you will be learning this week. So if you remember about 3 weeks ago, you did a lesson on dilations and scale factors. So what was dilations again? Dilation was when you took a figure and you made it smaller or bigger, and the scale factor was the fraction or the number that told us how much bigger or how much smaller we had to make something. So what we did for this example here, if we had a scale factor of 2, we had to take every x, y value and multiply them by 2. So if I go 2 times 2, we get 4, and 3 times 2, we get 6, and that gave us this new point up here. So scale factor, the number that told us how much bigger or how much smaller we had to make a figure. So tying that in with what we're going to learn this week, it's going to be all about similarity and scale factor. So similar figures is when all the dimensions have been blown up or shrunk down by the same number, the same scale factor. So let's take a look at this cone over here. This cone has three dimensions. It has a height, it has a radius, and then it also has a slant height. If I'm going to change one of those dimensions, I would have to change all three of them. For instance, if I wanted to keep these figures similar, I can't just change the height and keep the radius the same, because that would not give me a similar figure. I can't also just change the radius and leave the height the same, because that's also not going to give me a similar figure. I would have to change every single dimension by the same number. So for instance, if my radius here was 3 and my height was 4 and my slant height was 5, and say we took this similar cone and we made it 3 times bigger. Well, if I made the radius 3 times bigger, 3 times 3 would be 9. If I made the height 3 times bigger, 4 times 3 would be 12. And I made the slant height 3 times bigger, 5 times 3 would be 15. So this would give me a similar figure as if the scale factor, when I put all of these dimensions in fractions together, is going to give me the same number. Every dimension has to change. Same thing for the cylinders here. I can't just take a cylinder and change the radius and keep the height the same. That's not going to give me similar solids. And I can't just change the height and keep the radius the same. That's also not going to give me similar figures. So what I would have to do is change every dimension by the same number called our scale factor. So in this example, if we took the radius as, I don't know, let's say 10, and we made the height 12, and we want to shrink this cylinder down by exactly half, so we made our scale factor a half. Well, half of 10 would give me 5, and half of 12 would then give me 6. So just wanted to take a moment to tie in the whole dilation thing. For this unit, we don't have the x and the y coordinates, but the idea is still the exact same. The scale factor is the number that tells me how much bigger or how much smaller we can make a figure.